In this video we have more about the graph of a rational function. It's a continuation of the last video, or a part 2 if you want. So this one says analyze the graph of f of x equal 2x over x squared minus 9. This is a rational function. We went over some of these concepts in the last video. And this one says to analyze the graph. Now we're not going to graph it, but we're going to look at some of the details that we want before we graph. So when you sketch the graph of any function, you always want to know, does it have any intercepts, x and y intercepts. Now if you get a rational function like this one here, we know we can have vertical asymptotes, horizontal, or in some cases oblique or slanted ones. So we know that if I evaluate this function at f of 0, in other words, replace the x by 0, put a 0 there, get 0 and negative 9 gives me 0. So this suggests that the point where the graph passes to the point 0, 0, which is the origin. So if you want to find the y-intercept, where the graph crosses the y-axis, you place the x by 0. And if you get a number, that will give you the y-intercept. So if I replace the x by 0 here, I'm going to get 0. So this represents the y-intercept. If you want to find the x-intercept, you replace the y by 0. So put a 0 where this is, solve this equation for x, and the only value that's going to satisfy this equation here is going to be 0. So 0, 0 is an x and a y-intercept. So we have that information. Obviously we know that for a rational function, any number that makes the denominator 0 will lead to a vertical asymptote. So if I factor this out, I can see that 3 makes the denominator 0, and negative 3 makes the denominator 0. And as long as those numbers don't make the numerator 0, those are vertical asymptotes. So x equal 3 and x equal negative 3 represent the equations of the vertical asymptotes. Now if you have a rational function where the degree of the numerator is less than the degree of the denominator, which is the case here, this has degree 1 here because of the x, and 2 over here because of the x squared. So a horizontal asymptote would be y equals 0. So here's what we have then. The domain is the same values that make the denominator 0. It's undefined there. So the permissible replacements for x would be any value except 3 or negative 3, because those make the denominator 0. Division by 0 is undefined. And those values will also give us the equations of the vertical asymptotes, as I just pointed out, x equal 3 and x equal to negative 3. Horizontal asymptote would be y equals 0, which is the x-axis. So in general, the asymptotes are lines. They could be vertical, horizontal, or slanted that the graph approaches, and generally doesn't touch. For sure, the graph will not cross a vertical asymptote because that's where it's undefined. It can cross a horizontal. So this is the information we have there. Now the other information we need in order to sketch the graph is where is the graph above or below the x-axis. So the key points we plot here will be where the vertical asymptotes cross, because that's where the graph is undefined, and also any intercepts, in this case at the origin. So infinity is over here and negative infinity is over here. So let's look at what we have here. We want to know where's the graph above or below on this number line. So let's start on the left side. If we pick a number less than negative 3, say negative 4, put a negative 4 here, that'll give me a negative number, the negative value there could be negative 4 times 2, and then a negative 4 here will give us a positive. So in this case right here, I get a negative. So negative means below the x-axis, so the graph is below. On the interval from negative infinity to negative 3, the graph is below. What happens between negative 3 and 0? Well, let's pick a negative 1. This will be negative, and then this will be a negative. So negative divided by negative, here I get a positive. So the graph is above the x-axis. Now what happens between 0 and 3? Let's pick a number between 0 and 3, say 2. 2 times 2 is positive. B2 squared is 4 minus that. That's negative. So I get a positive over negative. In here, it's going to be negative. Now, what happens from 3 to infinity? So we can pick any number to the right of 3, say 4. So put a 4 here. 4 times 2 would give me a positive. And 4 squared would give me a positive minus 9. It's still going to be a positive. So positive over a positive will be a positive. So that gives you a good idea as to what the graph is doing. So I know that in here to the left of negative 3 is going to be over here somewhere. This is going to be, this number represents a vertical asymptote. So what's going to happen is this. The graph is going to look like this. That it can stay below here, above here, and down over here, but I have a vertical asymptote. So just use common sense. We know the horizontal asymptote is the line y equals 0, which is the x-axis. So we're going to use this diagram right here to sketch the graph. So let's start on the far right. You can start anywhere you want here, but we know it crosses at the origin. And that's the only point it crosses. And keep in mind that the graph will never cross a vertical asymptote, because that's where it's undefined. It may cross a horizontal. Generally, it doesn't. So let's start on the right side here. I have a plus right there, so I know the graph has to be above. So just common sense. I have a vertical and a horizontal. So without plotting any points, you just draw the graph. This is just a sketch of the graph. Draw it so it approaches the vertical and the horizontal. So it goes something like that. But this line goes on forever, so this is going up like that. This is just a rough sketch. Now in the interval from 0 to 3, I have a negative. So I know the graph stays below the x-axis. So I know it passes there, so I have to connect it to this point. And then because I have a vertical, it has to come down like that. Between negative 3 and 0, I have a plus. So the graph has to stay above the x-axis over here. So common sense again. I got a vertical. I know it can't cross the vertical, so draw it so it approaches it like that. And then what happens to the left of negative 3? I have a negative. That tells me the graph has to be below the x-axis. And again, I have the horizontal asymptote, y equals 0, and the vertical. So it stays below, so just common sense. Draw it so it approaches the x-axis, which is the horizontal asymptote, and the vertical. There it is. We said that the graph never approaches, or never crosses, I should say, the vertical. And we said that in general it doesn't cross the horizontal. In some cases it does. This is one case where it does pass or intersect the horizontal asymptote right there, 0, 0. But the x-axis is still considered a horizontal asymptote because as x goes to infinity, this graph approaches this way. It never touches again. Touches there, and then on the other side, as x goes to negative infinity, again the same thing happens. It never crosses right there. But then as x goes to infinity or minus infinity, it doesn't cross. And of course, how do you know that it doesn't cross? How do we know that if I extend this line, this graph goes like this and crosses there and then comes back up and never crosses again? Well, I know it doesn't cross again because if it crosses this line here, I'd have to have another x-intercept, and we only have one. So just using common sense, then we know that this is the graph for that rational function. And then we have one application here. A company that produces snowmobiles has a cost function, C of x. Find the average cost function. So for part A, C is a cost function, and then C bar is the way we define the average cost function. And this is simply defined by the cost divided by the number of units, in this case x. So C of x is this. So this will be given, the average cost function will be given by 3,500 divided by x. The x cancels there. This will be 150,000 over x. So that's the answer to part B. Your cost function, your average cost function is cost over x. We get this right here. And for part B, What is the average cost of producing 100 units? You simply take the average cost function, evaluate it at 100, plug it in here, 150,000 over 100, add it to 35, that's 1,535, 100, and give me 5,000. And that's in dollars. Thanks for watching. We'll see you next time.